Hey guys, it's Miss Gray, and for today's topic, balancing redox reactions, this can get a little complicated, so I asked for help. Mrs. Ui's here.
Oh, yes.
Yes.
As if I can
So
help.
I've got some support here. Buckle your seatbelts, guys. We're going for a ride. Balancing redox reactions. If we have acidic conditions, we have a different set of rules than basic conditions. So let's go through step by step, and then I'll show you a couple of examples. First of all, the idea here is to make sure that the electrons that are lost are equal to the electrons that are gained.
Yes, they should be equal.
Yeah, we're still following the law of conservation of mass.
Oh, yes.
Right,
It's
and
very important.
we have to use the half reactions in writing the net ionic equation. So we're going to break things apart into reaction for each substance. Which thing is reduced and which thing is oxidized. Step 1, divide into two equations, right? One for oxidation and one for reduction.
And then the second one is?
Then balance each half reaction. So if you divide your equation and you have both things being reduced, you better check your oxidation numbers. I've done that before. Doesn't work. All right, then you'll balance all of the elements other than hydrogen and oxygen first. So like chromium and manganese, balance those. And then we'll worry about oxygen and hydrogen. We're going to balance oxygen just by adding water.
That's easy.
Yeah. And then you'll know how many hydrogens to add to the other side because the water has hydrogen in it. So you have to make that balance by adding hydrogen ions. And this is why we said under acidic conditions, we can do this rule because acid makes hydrogen ions.
Yes.
Okay, so some of the electrons are coming from the acid that's in the beaker too. All right. So we're allowed to do stuff like that. The next rule is to balance the charge by adding electrons. And sometimes I do this as I write the half reaction. You don't have to go exactly in order of electrons and then the atoms. Sometimes I do electrons first. Then we multiply the reactions by a whole number so that the electrons are equal. So if I had one thing lost 2 electrons, the other thing gained 3 electrons, we have to make it balanced.
Yeah,
so
it's not equal. 2 and 3 is not equal.
Right, exactly. And we'll have to use the least common multiple.
Yes.
And then we add the two half reactions together, cancel out like terms. And then we have a whole reaction that's balanced. Double check.
Just make sure.
Yes.
Double check your answer.
Always double check. All right, so let's work through a real example and do
that
each
sounds
step.
easy, Ms. Gray, but let's see.
It sounds easy. I'm glad you think it sounds easy. I already told them how hard it would be.
It only sounds easy.
I was just playing.
But I don't know if we're going to do
it's not hard. Well, let's see which one is oxidized and which is reduced. Okay, so for this permanganate ion, I have a total charge of a -1. And the charge of oxygen is always -2. And how many oxygens? 4 in this. And then I have some of this charge is coming from the manganese, but I don't know how much.
Yes.
All right, so that's what we're trying to figure out. What's the oxidation state of manganese?
Okay.
So I have here x minus 8 equals -1. So we know x is equal to +7. That's what manganese has for its charge.
+7, okay.
Okay, so now compare that to manganese on the other side. It's a +2.
+2.
Right, so it went down. That means it was reduced.
Yes.
Remember Leo says grr, gain of electrons is reduction.
Yes.
Okay, so we know that manganese in the permanganate had to gain electrons to turn into this manganese ion. Okay?
Yes.
So how many electrons? We went from 7 to 2. That
so
would be
5.
Yeah. So that's how we decide which is oxidized and which is reduced.
Okay.
Okay, let's do the same for oxalate.
All right.
C2O4 is oxalate. So we have a -2 charge. And then each oxygen is a -2. There's 4 of them. And then we have 2 carbons. All right, so now I get 2x minus 8 equals -2. And 2x equals +6.
+6.
So x is 3. All right, so in oxalate, the carbon has a +3.
Yes.
Okay, now let's do the same thing for the carbon over here. For a compound, notice there's no charge written up here. That's because it's a 0.
It's a 0.
Compounds are neutral, right? And then we have 2 oxygens that are each a -2,
Mm-hmm.
and only one carbon. All right, so x minus 4 is 0. That means each carbon in carbon dioxide is a positive 4.
Positive 4.
All right, so let's hope this worked out okay.
Mm-hmm.
Our oxalate went for carbon from a +3 to a +4.
Plus 4.
Okay, so that means it's going up. Good, because when we had something going down here, we wanted to have something going
Yeah,
up there,
going up.
right? So this is the thing that was oxidized,
Okay.
right? And now we're going to use those half reactions. Now that we know which things
Which things, yeah.
we're going to use the half reactions to balance this equation. So the first step is to write a half reaction for the reduction bit
Okay.
and another one for the oxidation.
Yes.
Okay, and I'm going to go ahead and write in our oxidation numbers so we remember what was what. This was a 7, and this was a 2. That's already there. And then here we have 3 and a 4.
4.
All right. And of course the oxygen's a -2. The only time it's not -2 is when it's in peroxide.
Okay.
All right, steps 2A and 2B go like this. Balance everything besides oxygen first.
Mm-hmm.
Okay, so we had
Balancing
one manganese and on the other side one manganese.
Mm-hmm.
Easy. And then we balanced oxygen. How many oxygens did I need? 4.
4.
So I added 4 waters.
Okay, so it's balanced.
Right, so the oxygen is balanced.
Yes.
Okay, now let's do the same for the oxalate. I have here 4 oxygens,
Mm-hmm.
and on this side 1.
1.
No, 2.
2.
Oh, right, because look, I have to balance carbon dioxide. Right here, oh, wrong color. Right here I had 1 carbon dioxide.
Mm-hmm.
I changed it to 2 because I need 2 carbons.
Yes.
So we take care of the things that are not oxygen first,
Oh, yeah.
right?
Okay.
Okay, so now I have 2 oxygens. That's not going to work. I'm going to have to add some water. Did I do that? No. Why? I was being silly. Let's get some water in there. I need 2 more oxygens, it looks like, right?
Okay, so 2O.
2 H2O.
Water. Okay.
Add water. Okay, the next step, part 2C, is to add hydrogen ions to balance out the ones from the water.
Yes.
Okay, so I have 4 waters.
Mm-hmm.
That means 8
8.
hydrogen ions.
4 times 2 is 8, yes.
Okay, now I messed up this part. I needed 2 waters here to make everything balanced.
Mm-hmm.
No, I didn't, because I forgot the 2. That's why I didn't have that the first time.
Yeah.
I don't need any more waters here. Wow, if you don't write the problem correctly, you'll have a hard time solving it.
Oh, yeah.
Yes. Okay, so now I have 4 oxygens and 4 oxygens. We're good to go. Sorry.
That's balanced, yeah.
Yep, okay. So I don't have to add waters to this next part.
Mm-hmm.
And I don't have to do hydrogen ions either because I didn't have water.
Yeah, you don't have water.
All right, good. So the next thing I have to do is the electrons. We said that manganese gained 5 electrons.
5 electrons.
And carbon, to go from a 3 to a 4, had to lose 1 electron.
Okay.
Okay, but there were 2 carbons. That means each of these carbons lost 1 electron, but there are 2 of them,
Yeah.
right? So I have 2 electrons,
2 electrons.
as a product because it got rid of them.
Yeah.
All right, well, 5 and 2 are not going to balance.
Yes. 5 and 2 is not the same.
Right, so that is why we have to do the next step. Oh, it's thinking. Sorry, didn't mean to be pushy there, computer. In our next step, I'm going to multiply the 5 by 2.
By 2.
And then the 2 will multiply by 5. Because I need to get my electrons to balance.
Equal, yes, balance.
Yeah. So now I have
10 electrons.
and 10. Perfect. Because what I
now
want
they're
them
balanced.
to do is to cancel away.
Mm-hmm.
We have to have them balanced, but then that means they're gained by one thing and lost from one so they can be
Yes.
gained by the other. Right? Then we add our half reactions together, and believe it or not, that is what the balanced reaction looks like.
Wow.
Yeah, for a redox reaction.
Yes.
So these can be time consuming and they take up a lot of space.
Yes.
But work your way through the steps one thing at a time
Mhm.
because it wasn't that hard.
Yes. And good thing they can pause and rewind, right, Miss Grace?
Yes, if you need to pause and rewind.
Yeah.
See that again. That's fine. We're going to do another example.
Yay!
Yep, double check
forget to
atoms and
double check.
charges, right?
Yes.
We got it. I've checked and checked and checked. All right, well, let's do another one without looking at the rules. Oh, this could be tricky.
Ooh.
All right, this is going to require on our knowledge of solubility rules. Okay.
Yeah.
We have an acidic solution, so there's our key. We get to use the adding hydrogen
Adding
ions.
hydrogen.
And we have potassium dichromate.
Mm.
So that's K2,
K2.
Cr2O7.
Wow.
That's
You
potassium
know it, Miss
dichromate.
Gray, huh?
Of course I did. I memorized that ion card. I made
Yeah.
my students do it too. All right. And now this is an alkali metal. And I said we have to use solubility rules.
Solubility rules.
Alkali metals are always soluble. So I'm going to split this up. I have potassium ions and I have dichromate ions.
Cr2.
So I have both of those in solution.
Mm-hmm.
All right. And then I have iron 2 nitrate. Okay, what do you know about nitrate and its solubility?
Nitrate. Oh
Anybody want to hang out with that guy?
my.
No.
No?
See his name?
Oh,
No.
yeah. You mentioned that to me.
Right, right. The knuckle-noso.
Knuckle-noso.
rules. Yeah. All right, so here's our iron 2 nitrate, and that's going to always be soluble.
Mm-hmm.
So do you suppose we really need these spectator ions? Nah,
No.
we don't need those.
Yeah, we don't.
They're
need
just
them.
going to get in the way.
Yes.
All
So
right.
get rid of.
No,
Just
wow.
crush them.
I didn't tell anybody what the products are going to be.
Oh.
So they're just going to have to trust me here. Dichromate in acidic conditions turns into chromous ions. I think that's okay.
You
I
need
don't
more
have
space?
to. No, I just. There we go. I need to see what it's going to do. Dichromate, chromium 3. Ooh, I
Chromium
put
3.
chromium 2. Good thing I checked.
Yes.
All right.
That's why it's important that you're going to check.
Yes. We won't make that mistake again. Chromium 3. There we go.
Okay.
So dichromate turns into chromium 3. And we have two choices for iron.
Mm-hmm.
Because it could go to 0 and be
Yeah.
a metal, or it could go to the +3. And it would be very rare for it to go to a metal, so we're never going to do that.
Okay, so let's use +3.
Yeah, exactly. So any metalless ion turns into metallic. All right, so now we got to decide what's going up and what's going down.
Okay.
All right. I can tell easily what iron's doing.
Yes, it goes up.
Yeah, so
So
that's being
it's
oxidized.
Oxidized.
Yeah. Now let's look at the dichromate.
Dichromate.
It has a -2 overall.
Mm-hmm.
Oxygen
two.
is 2-, and there's 7,
7.
and then 2 chromiums.
Yes.
All right, so 2x minus 14 equals -2.
2.
2x is 12,
16. Oh, 12. Yeah.
and then x
That's
is
6.
6. Great. So we go from a 6 to a 3.
So it reduced.
Yes, it went down, which
Yes.
is good because our iron went up.
Yes.
One thing goes up,
All right.
one thing goes down. If
Mhm.
both are going up,
Oh,
that's good.
not good. All right.
Okay, good. So I need more space to solve this. I'm just going to get rid of this writing. We know dichromate and iron are the ones we need. So Cr2O7, 2-, and then we went to chromic.
3+.
All right. And then iron 2 goes into iron 3.
Iron 3.
So that's our bare bones for the reaction.
Okay.
Great. Now let's balance for everything but oxygen first.
Mm-hmm.
I need then 2 chromiums.
Yes.
All right. Now I got to balance, no oxygen here.
No,
We're
yeah.
good. Now let's balance for oxygen. I need 7 of them. So let's add 7 waters. Okay.
Mm-hmm.
And now how do we balance the hydrogen?
Hydrogen.
I need 14 of them. So I'm going to add 14 hydrogen ions out here because we're in acidic
Yes.
conditions. All right. Now the only thing left to worry about is electrons.
Electrons.
So to go from, this was a 6, right? From a 6 to a
Yes.
3,
To a 3.
I need to add
3 more.
electrons
Yes.
each for each chromium.
Okay.
So that's a total of 6
6.
electrons. Okay, that's not too bad. Now let's do the electrons for the iron half reaction.
Mhm.
We've been ignoring iron because it didn't have oxygen, so that was easy. All right, but he obviously gave away one electron to go from a 2 to a 3.
Yes.
All right, well, this multiplication should be easy. Now I need to make sure they're equal, right? So how do I get 6 and 1 to be equal? We just multiply this one
By 6.
Okay, so I'm going to rewrite it so I don't confuse myself. I have, here's my oxidation, half reaction. I need 6 of each thing and then 6 electrons.
Yes.
All right, so that's a goner,
Mm-hmm.
and it's replaced now. Okay, I think electrons are balanced. Everything, all the atoms are balanced. Now we're ready to add the half reactions together.
Okay.
Okay, so
We're not done yet.
we just take what's on this side
Yes.
and call that our product. So I have 14 hydrogen ions,
Hydrogen.
and then
Cr-
1 dichromate,
dichromate
and the
oxygen.
electrons canceled,
yes.
okay, because they are the same on both sides.
Mhm.
But also I have this on the reactant side, 6 ferrous ions. Okay, and that's going to turn into 2 chromic ions and 6 ferric ions and
7 waters.
7 waters. Don't forget your waters.
Mm-hmm.
And that's it. So now we have balanced this reaction. It's really long.
Yes.
These turn out to take some time,
Mm-hmm.
and they look really long. So in your net ionic equations on question number 4 in your AP Chem exam, if you see something that says dichromate and it's not double replacement,
Mm-hmm.
or if it says acidic and dichromate, you're going to have to do this. Start with this one so that you'll have plenty of time to get it done.
Okay.
All right? You don't want to spend more than 10 minutes on question number 4.
Oh, yeah.
So this one takes time. The other ones will go quick and easy.
Yeah.
All right, well, let's look at a different set of conditions.
Still thinking?
Yep. All right, balancing redox in basic solution.
In basic solution.
Right, so it's almost exactly the same, except we don't have hydrogen ions in a basic solution. That's okay. We're going to add them there at first.
Yes.
And then here's our trick in a basic solution. We add hydroxide to both sides. And then on the side where we had hydrogen ions, we have hydrogen and hydroxide both. We just call that water.
Water.
Okay? So we do it the same way, only we're going to use hydroxide because now we're in basic solution.
Okay.
So it's essentially the same.
Same rules.
Right. We're going to go the same steps in the same order, only this time we're going to have to use hydroxide instead of those hydrogen ions. We can't have those hanging around because it's not an acid anymore.
Yes.
All right. Well, let's see one, and then we'll try one.
Okay.
So we have a solution of potassium permanganate mixed with an alkaline solution of sodium sulfite. All right, so here's our clue that this is a base, alkaline solution.
Alkaline solution.
Right? And potassium and sodium are spectators, right? Naco-no-so.
Yes,
right.
naco-no-so.
So we have permanganate, MnO4 minus, and it's going to probably turn into manganese ions.
Mm-hmm.
No, it's not. Not in basic solution.
Oh.
No, I know.
Do they need to go ahead and check their notes on that, Ms. Gray?
Yeah, let's go ahead and do that.
Let's go ahead and check that to make sure.
See if I can.
So it's very important that you have that paper handy.
Yes.
By your side.
Right, and notice here, I wrote them a note, make flashcards to memorize.
To memorize.
Yeah, so for now, it's okay to look at this.
Yes.
Later on, not okay. All right, so here's our problem. We're in basic solution now. So MnO4 in basic solution is going to form MnO2. Yeah, that's why. Got to be all picky. So let's try this again. These are spectators, potassium and sodium, and then permanganate in basic solution is going to be MnO2. And then sulfite is this ion.
Mm-hmm.
Guess what? It's going to be sulfate.
Sulfate.
Okay?
All right.
So that's like our bare bones. And we want to see what's the thing that's going up and what's going down.
Yes.
Okay, so let's do some algebra. Permanganate is a -1 charge.
Mm-hmm.
And we have 4 oxygens.
4 oxygen.
Okay, and then 1 manganese.
Yes.
So I simplified the math. I hope everyone remembers oxygen was a -2, and we
Yes.
had 4 of them. right?
Yes.
That's where this comes from. So X
They
is
should know it, right?
7, right?
Yes.
Plus 7. Okay, let's look at it over here. We have a compound now, so it's 0
Mhm.
charge. And 2 oxygens
2
is
oxygen.
-4, and 1 manganese. So now it went from a 7 to a 4.
4. So it reduced.
Yes, it went down. Reduce. So we're going to have to gain electrons.
Yes.
And I'm just going to put that in. We're gaining 3 electrons here.
All
Okay.
right.
All right, let's do sulfite to sulfate.
And
All
see
right.
if it's reduced or
Yeah, let's hope it's oxidized.
yes. It will.
I hope so. All right, so we have 3 oxygens, -6, 1 sulfur. All right, so X is +4.
4.
All right, +4. And then in sulfate, we have a -2 still,
-2.
but there's now an 8. So that's a 6. Did we get oxidized? Yep, it went up.
Yep. It went up from
So-
4 to 6.
Yep, so that's an oxidation.
Yeah. So we're good.
Good. So now we know our starting place and where it comes from and why.
Yes.
Well, here we go. We added 3 electrons to the
Mhm.
permanganate. And then what did I do?
Why is it 4H?
Let's see. Manganese was balanced. Yeah.
Yeah.
Then we had to balance oxygen.
Mm-hmm.
So I added 2 waters to get 4 total oxygens.
So 2. Yeah.
So 2
4,
waters.
4.
Because I already had 2.
Yeah.
I'm pointing as if they can see. I already had 2 of them here. I needed 2 more to make 4 oxygens.
Yes.
So add water to balance your oxygen.
Exactly.
And then I had to balance my hydrogen ions on the other side.
So that's 4.
Right, 4 hydrogen ions.
Mm-hmm.
But we're in basic solution. So I can't leave it like that.
Yeah.
Now, since I have 4 hydrogen ions to get rid of, I'm going to add 4
Hydroxide
right here. And if I added them on this side, I have to add them on this side
on
as
the
well.
other side too. So whatever you do on the other side of the equation, you have to do it, right?
Right. And remember, hydrogen ions and hydroxide ions join together to make water.
Yes.
Okay, so look, I have 4 and 4. That makes 4 waters.
4 waters.
All right, so there they are, my 4 waters.
Mm-hmm.
Now, we're not done. I have 4 waters on this side and 2 waters on this side.
Yes.
All right, so that means really I just have 2 waters left.
Yes.
Right? Because if it's on both sides, we can cancel it out.
Okay.
But I could only cancel 2 of them.
Yes.
All right, so that's the half reactions for the manganese. Oh, look, I showed that. Let's try the sulfite to sulfate.
Okay.
Okay, so that was an oxidation from going to, let's see, from a +4 to a +6.
+6.
So I had 2 electrons, and I have to balance oxygens. See, on this side I had 4,
4 oxygen.
and here I had 3.
3.
So I just added 1 water.
Okay.
All right, and adding 1 water, I gotta balance these.
H2.
So there's my
there's balance.
hydrogens.
2 hydrogen ions.
I should have minuses on my E's.
Mm-hmm.
Now I can't keep those there because we're not in acidic conditions.
Yes, we're in basic, right?
Right. So how many hydroxides should we add to this? To balance 2, I
1,
need
2.
2. Yeah. To balance 2 of these, I need 2 of those.
Oh yeah, because 2H. Yes.
Yeah. All right. So, well, can we still see? I've scribbled everything out now. Yeah, I added 2 hydroxides.
2 hydroxide.
And then over here, I had to add 2 hydroxides.
2
also.
hydroxide also to make it balance.
Right. So now these join together to make 2 waters.
Mm-hmm.
And I already have 1 water over here. So I have 2 waters here and 1 water here. Now I can cancel just one of these.
Yeah.
Okay, I think I already did in my next. Yep.
Yes.
So get rid of those. And then there's
To balance.
electrons. Oh yeah, because I had 2 electrons in this reaction and 3 electrons
3
in this one.
electrons.
All right, any ideas?
So we need to balance the E's, or the electrons.
Right, so we'll use the least common multiple for that.
Okay.
Let it think.
Peter's
The magic's
thinking.
spinning. And clear off all my scribbles. So to get to the least common multiple of 6, I multiplied the one with 3 electrons by 2.
By 2 and the other one by 3.
And the other one by 3. Right. So there's the result of that. What am I crossing out? Oh, waters. I didn't know what that was at first. Okay, so let me just be sure everyone sees. In the permanganate reaction, we had 4 waters.
4 waters.
And in the
We only have 3.
sulfite reaction, we had 3 waters, right?
So cancel just
So-
cancel 1? Or-
Right, so we're left with 1.
Okay.
Okay, how about this hydroxide and this hydroxide? If they're on opposite sides of the equation,
You
can
just,
simplify.
Yeah, simplify.
yeah, so I'm left with 2 hydroxides.
Yes.
And then the electrons cancel. Let's add up the 2 equations, and there we are. That's how we
That's
balance
our balance.
in basic conditions.
Wow.
So balance everything but oxygen first, balance your electrons, then use the water to balance everything
Yes.
else. Okay, now we have a challenge.
Ready for another?
Yes, now this is one I have never tried before.
You can
Well,
do it, Miss
that's
Gray.
not true. I did try it before, but because I wrote it down incorrectly,
Yeah,
I got the wrong answer.
but you will get it this time.
Yes, this time I have it written
All right,
down
let's
correctly.
just follow.
Okay, so let's see what's oxidized and what's reduced.
Okay.
Bismuth is easy to tell because it goes from a +3
Oh,
to a 0.
so it reduced.
Yes, that one went down.
Went down.
So that's our reduction. So we expect for tin to be oxidized.
Yes.
And it looks like it has been oxidized because there's more oxygens on it.
Mm,
And one
it goes
definition
up,
of
yeah.
oxidation is to add an oxygen
Add
to
an
it.
oxygen.
Yeah. So let's see what's the charge on our tin. In this case, we have x minus 4 equals minus 2, right? Because oxygen, there's 2 of them.
Yes.
All
So
right.
that's x is equal to 6.
Nope.
No,
Negatives and
Negatives,
positives.
yeah.
So it's a 2 plus.
2 plus.
Okay, so that we call stannous.
Oh, yeah.
And so maybe we'll get stannic on the other side.
Maybe.
Oh,
do
let's
it.
see. Minus 2. And then 3 oxygens,
3 oxygen
minus 6. And x. Hey, we sure did. That's a plus 4.
Plus 4.
So that's our stannic
Yes.
ion. All right, if we're getting things that make sense, that makes me happy.
Yeah.
Okay, did we go up though?
Yes, we. Yeah.
Yeah, tin went up 2 to 4.
So that's oxidized.
Yep, that one's oxidized. Good. So we know we have a good skeleton.
Yeah.
It's already working better than the last time I tried. Good.
Told you you can do it.
I can. I'm glad you're here to support me. Let's write 2 half reactions. So I'll start with bismuth because that one looks easy. There's my 3 plus. And here's my tip of the day. If you put your arrows down the middle of your page, you'll have more room
Yeah.
to balance
Okay.
this. If you
a
start
good idea.
on the left, you won't have room to add, and
Yeah,
it will
you
be a
might
mess.
have to redo your solution.
Right, exactly. So we said this is reduced, which means it gained electrons, so I have to put them here.
Plus.
So 3 to 0, we had to gain 3 electrons. Okay, and then let's do tin. We went from tin 2 to tin 4. That sounds like an army command. Tin 2, tin 4.
10, 4.
Tin 4. Trucker talk. All right, so we went from a 2 to a 4.
To a 4.
We lost 2 electrons.
Yes.
All right. Now I see a problem with our oxygens. Tin is balanced.
Yeah.
Oxygen is not
Oxygen
balanced.
is not. It's like 2 and 3.
Right. Let's have another one over here. So I need 1 water over here. And the next step is to balance hydrogen. So I gotta have 2 hydrogens
2
over
hydrogen
here.
in there.
Okay.
2
I'm already running out of room. See that? All right. And I can have hydrogen ions because we're in basic solution. So I better add 2
OH,
hydroxides to
hydroxide.
everything over here and over there. 2 hydroxides. Okay, so what that accomplishes is now I have 2 waters here.
2 waters, yes.
Okay, so I'm just gonna scribble. 2 waters and 1 water here.
1 water there.
Well, let's simplify that. Overall,
So
that
we're
means
left with
1 water.
1 water.
All right, bismuth is good. That part was easy. But now I think we're ready to add our half reactions together.
Yes.
No, wait. We have to fix our electrons.
Oh, yeah, electrons first. Don't
Yeah.
forget your electrons.
Yeah. So
So we
I
have 3,
3
and then you have 2.
All right. So
I think that's easy.
Yeah, not too bad.
2 and 3.
Okay, good. We can do this. I'm just going to rewrite down here 6 electrons plus bismuth. What do we call that? Bismuth-ic? I've never heard of that before. Oh wait, I have 2 of these. I'm multiplying everything by 2.
Yeah, by 2.
I almost forgot. Only
Okay.
don't just multiply electrons.
All right, so you have 6 OH plus 2, 3 SN.
Right. SNO2.
SNO2.
I don't even know what to call that.
I know, me too. So let's
And
just say
oh wait, multiply
3.
3 of those.
Okay, and then that's 6.
Okay.
6 electrons.
Oh, and I'm not done because I have these waters hiding up here.
3 waters.
Okay. Wow.
Ooh, that's a long.
That's a lot of stuff.
Yeah, that's a lot of stuff to write.
All right, let's
It's very
add them together. 6 electrons cancels. All right. Any waters?
Water, no water.
Nothing else to cancel.
Okay, 6.
All right, 6 hydroxides and
3 SNO2.
2 minus.
2 minus.
And bismuth, 2 bismuth ions. That's it, right?
Yes.
Okay, good.
And then we have 3
3.
SNO3, 2 minus.
All right.
Plus 3 H2O.
Okay.
And then 2B bismuth.
Right. That's it. We did it.
Yay!
Bravo.
6. Yay!
Everything's balanced. Let's see. 10 is 3 and 3, and 6 and 6 oxygens. Hydrogens, I have 6 over here.
How come we only have...
Oh, right, because some of our oxygens are in here. We have 9.
9.
And 3 is 12.
12.
And 6 and 6 is 12.
12. Yay!
Good. And then bismuth.
And then 2 bismuth.
2 and 2. Life is good. Double checking is good.
Yes.
I did it. I did a redox in
But for
basic
Miss
solution.
Gray.
Those ones have always kind of been tricky for me. But now you've all witnessed my success. Okay, one more.
One more.
This is the one we're actually going to do in our next lab, the redox titration lab. So I wanted to make sure they could do this.
Yes.
All right. The first thing we did before was to identify oxidation states.
Yes.
But we've done this one before. Carbon was a +4 here and a +3 here. And manganese is a +7 here and a +2.
A +2.
All right, so the more you do these, the more you'll just know that manganese is a +7.
Yeah.
Right? And that oxalates carbon is a +3.
They just have to pay attention.
Right, and
Yeah.
they have to
Pay
do
close
a lot of
attention.
practice.
Practice makes perfect.
And since I know that's what they need, why, that's what they're going to get.
Yeah.
All right, let's write half
Take it from
reactions.
Ms. Gray.
Yep. Manganese is being reduced.
Reduced, yes.
All right. Because we
Yes,
went
from
from
7 to 2.
7 to 2. So let's do our electrons right now.
Electrons is
5?
5?
Let's see. 5 electrons, and we gained them because it was reduced.
Yeah, so 5E.
All right, good. Now let's do oxalate, C2O4.
We know that it oxidized, right, Ms. Gray?
It went
Because
from
it went
a
up
3
from 3 to 4.
4. All right, so that means it gave away 1 electron for each carbon.
Okay.
But there's 2 carbons here.
Yeah, so 2E.
So 2 there. And I'm going to go ahead and balance the carbon. Okay. Great. So now everything except for oxygen is good to go.
Yes.
Now let's take care of oxygen. In the permanganate part of the reaction, I had 4 of them.
4 oxygens.
So let's add 4 waters.
Yes.
Okay. And then how many hydrogen ions will I need?
You need
8, it looks like.
yes, 8. 4 times 2 is 8. Yeah.
All right, now let's check over here. Oxygen was 4 in here.
4, and then we have 4 right there.
4 right there.
Okay.
So I don't have to mess with that. Yay.
What
Don't
about-
have to mess. Good. Now, electrons.
Okay, so you have 5 and 2
Okay.
multiplied by
So we'll just
5 and 2.
flip-flop.
Yeah.
Okay, so I'm going to rewrite. Now
So
I have
that's 16H.
16 hydrogens
And then you have
and
10
10
E.
electrons
And then you have 2
permanganates
permanganates.
and 2
2
manganese.
manganese. And then 8 waters.
Okay. Boy, these get to be long.
All right.
And then down
We
here,
have
5
5.
oxalates. It's easy to mix up oxalate and chromate.
Yeah.
But if there's not an R, it's
Yeah.
oxalate. And then
You have
10 carbon dioxides
and
and
then 10 electrons.
10 electrons. Okay.
Oh, there I see 10 electrons and 10 electrons. So
Okay, they're goners.
cancel that. Yep.
Great. Let's add the half reactions together.
Do you have more room to write?
Yeah, I think so. We'll be all right.
Yeah.
So 16 hydrogens.
Mm-hmm.
Electrons are gone.
Yes.
Okay.
2
what is that? Permanganate.
permanganate.
Right. And then 5 oxalate ions.
Mm-hmm.
So looks like our mole ratio here is 2 to 5. That's going to be important in the
Yeah.
titration. Because you have to
Oh,
have
the
2 to 5 ratio. All right, then 2 manganese ions,
Plus
8 waters,
and
and
then carbon.
right, 10 CO2s. Whew, we barely squeezed that all in.
But you're good.
Yeah, so
Okay.
there's no other way to balance these kinds of reactions. There's no way you could have possibly predicted that you would come up with that if
Yes.
you didn't do the half reactions first.
Exactly.
You have to do
That's
half
right.
reactions, and you have to know what's being oxidized and what's being reduced.
Exactly.
It's the only way to do it. So I appreciate your support.
Oh, are we done?
We're done. That's
Oh,
it.
I'm still waiting for one more.
Well, we could keep going.
Yes.
We'll let the kids do it.
All right. Yes.
All right.
You're right, Ms.
Thanks,
Gray.
Mrs. Zooey.